Hey everyone, what's up and welcome back to How to Become an Animator. I'm Sir Wade and today we are doing the video you've all been asking for a while, the Graph Editor Basics video. Now I'm going to be showing you how the Graph Editor works in Maya, but this is true for Cinema 4D, for Blender, for After Effects, anything that has a graph or a curve editor. They all have their different features and different things they can do, but at a base level they all work the same way. But today I'll be teaching you how the Graph Editor works and how you can use it to animate. Two quick things before we get started. If you're new to the channel, I do a lot of Maya videos and not just tutorials, but also just a lot of helpful information. And if you're interested in downloading project files, Q&As, that kind of stuff, head over to Patreon, links in the description. But for now, let's jump into the video. All right, so here we are in Maya. First thing I want to do is I'm going to switch over to an orthographic view, which basically just means left and right only. We don't have the ability to tumble around in 3D space. We just look at it from a side profile. Now, to get to the Graph Editor, you need to go to Windows, Animation Editors, Graph Editor. That will pull up the window and you can resize it, do whatever you want with it. I personally like to dock it at the very bottom, right above my timeline. It also gives me the ability to click on the tab and collapse the Graph Editor so that I don't have to have it there if I don't want it, but I don't have to worry about moving it around. So I'm going to grab the ball, hit S, set a key on all the attributes and all the different controls. I'm going to go to frame 8, and I already have auto key on. If you haven't watched my other video on 5 tips to know in Maya, you should definitely check that out. One of the things is auto key, which I've got on, and I highly recommend you do the same. I'm going to move the ball up, just kind of eyeball it and say that's good enough. So from 1 to 8, that's 7 frames. I'm going to go 7 frames forward to 15, and I'm going to drop the translate back down to 0. Now you can see as I set keys on the up and down, we're seeing this green line move around. And if you select any of the keys on it, you can see over here, the translate Y has a little marker next to it, meaning that this is the curve that we've selected keys on. I'm just going to select translate Y. Now what I'm going to do is I'm going to grab all 3 of these keys, Control C. I'm going to go to the frame where I want to paste right here, Control V, and it will place it down. You can copy a key from anywhere, Control C, but on whatever frame you are currently at on your playhead, or the yellow thing, that is where if you hit Control V or paste, it'll put it in the spot you currently exist at. So now I have 2 bounces, up, down, 2 bounces. However, if I play it from the beginning, you can see that there is motion there, but it's not a natural ball bounce because balls don't move like this. They don't have this smooth motion. That smooth motion is basically this smooth line that we see here. Now, before I go any farther, something extremely important you need to know about the Graph Editor. In this very particular case, when you're doing a ball bounce and you're doing the up and down of the ball, the actual motion of the ball and the way the curve looks happen to align and happen to look and act the same. That's not a normal thing. That's not something you're normally looking for in animation. Don't expect that your rotations and all of your translations are going to look the way they look in the viewport of a character doing a certain thing, and that it's going to exactly match the curve of a line, if that makes sense. These 2 things represent each other very well. This is something animation students struggle a little bit with, so I just want to address that. We'll come back to that later. So let's add a little bit more motion so we can see what's happening in the Graph Editor a little bit better. I'm going to grab the ball, and I've already set a key on frame 1. If I move to frame 29, I'm going to take my translation, and I'm going to move the ball in the X direction over to the right. Suddenly you can see in the Graph Editor, there's a new curve and a new color. Everything happening in Y, whether it's rotation, translation, or scale, is always green, where red is the X-axis and blue is the Z-axis. Now if I go ahead and play again, you'll see the ball is now moving up and down and left to right. So if I click on Translate X, you can see this line is now the left to right motion. Translate Y, still what it was before. Now they're just adding on top of each other and it's moving up and down and left to right. You get the idea. Now I'm actually going to delete the Translate X motion. I don't want it to go left to right. I just wanted to show you kind of how that works. So I just need to grab the keyframe, hit delete, and now we're back to just the green thing, just the up and down. Now let's start getting into it. We have a couple different types of lines, different interpolations or ways that the line is going to figure out how motion works. Right now the computer's going very smooth. So let's duplicate this ball. Duplicate, move, little trick there. Now if you duplicate an object in motion, generally it doesn't copy the motion. So what's very quick and easy to do is to take the one object, click on Translate Y, I'm going to grab this keyframe range, copy, I'm going to grab these 3 balls, set keys on all of them, and I'm just going to go to the Translate Y, paste. Next ball, Translate Y, paste. Next ball, Translate Y, paste. And so now all balls now have the same up and down motion. So copying keys is a really fast workflow tip. Now if I select multiple objects, you can see I now have all those objects over here on the left, and if I try to filter things, I just have to make sure I control click and filter all of the Translate Ys, which will then allow me, as I move through here, to move all of them at once. If you don't remember to grab all of them and you just say, oh, I want Translate Y, and you move one, it only does the one that you've selected. So just keep that in mind. So here I have 4 balls. If I play it, it looks like this. Now I'm going to take this first ball and I'm going to keep it in what's called auto tangent. So I'm going to grab all the keys and make sure that auto tangent is enabled. Auto tangent is basically the computer trying to make the smoothest curve it can make without really changing anything that you've done or doing anything beyond what you've expected. If I go to the second ball, I go to its translate, and I go to spline, it's actually not going to change all that much, but the ends will be different. Auto will just kind of flatten out if there's nothing beyond the keys there, where spline, it basically just says that whatever the curve was doing when it comes in or out of whatever keyframe, if there's nothing on the other side, it'll just continue doing whatever it was doing before. Now if we look at these two balls and look at where they are keyframed at their bottom and top of their bounces, it's the same exact location. But the way they get there, the timing of which they get there, and the spacing that happens as a result of that timing, that's what changes. And that's the whole point of the graph editor right there. So you can see as we scrub frame by frame, one of them goes slightly faster off the ground than the other one, and eventually they catch up to each other where that keyframe is the same. So it's that difference of motion that will give you the different feels of what these balls will be. Clamped is identical in this particular case. I don't have enough keys to show you what it really does. I don't want to get into it, but it integrates linear and spline in a different way when keys are close together. We're not going to go there. If I go to the third ball and change that one to linear, you can see that the lines lose all smoothness. They just go from point to point to point to point in a very mechanical motion versus like a smooth ease in and ease out. The fourth one here, flat, actually isn't going to make any difference in the current setup. So if I hit flat, nothing changes. That really quickly I'll show you if I add a few more keys in here. If I had auto, it would keep a pretty smooth line. If I show you spline, it will also try to stay pretty smooth. Things change a little bit. Clamped, again, is not gonna make too much of a difference at this point. Linear does its thing. But if I go to flat tangents, you can see how it actually flattens the handle of every single one, which in this case is gonna give you a really weird jerky motion. So let's just not worry about that one for now. So let's instead, first let me get rid of all these extra keys I put. I'm going to show you stepped tangents. What it's going to do is actually going to hold the position at whatever frame it's supposed to change. So if I go to frame 1, that's what it's at. And then at frame 8, it jumps over to what it is supposed to jump to. And the motion doesn't change or interpolate or smooth out, and it just jumps from point to point on the exact moment it's supposed to go there. So when you play them together, it definitely stands out as a weird one. So you hear a lot of people when they say they're in stepped mode, it's when people are blocking things out and they're just trying to kind of get their poses there and they're not yet tweaking the motion. It's just to hold your spot. I'm not going to get into plateau tangents because I've never used it and I'm sure there's a use for it, but I don't know. I'm going to skip that one. If I add a new key in here and I just move it up and I just create kind of an unevenness, how there's kind of a bump here. If I grab all these keys with auto, it will smooth it out without putting anything beyond what I've already kind of set for it. You'll notice that nothing is above or below any keys that I have manually created. Undo that. Or if I go to spline, you can see that it's similar. It is smooth, but comparing that to auto, you can see that not only are the beginning and ending ones different, but if I zoom in right here, see how when I'm in auto, this is still the maximum location, but if I go to spline, this allows an overshoot to happen where a new part of the curve is created higher than where I had initially intended. So let me show you here. If I just create a whole bunch of keys and they're all on auto, it'll try to go smooth. If I go to spline, it'll still go smooth, but it will kind of take some liberties and do some different things here. But if I go to flat tangents have their uses, but you do not want to use something like this for most natural organic motions. You're going to get this weird jittery, almost insect-like motion. Now let me delete these two balls. I'm going to put them back in auto. So they're both going to move very smooth and computery. It starts at the ground and it hovers, speeds up, slows down. It gets to the top and then it starts to come down slowly, gets faster, but then it slows down again and then just kisses the ground and repeats. So you get this kind of floaty motion up and down. Gravity is not really at play here. Now, I love physics. I'm fascinated by motion and physics, and I really liked that class when I took it. A lot of people hate physics and maybe never took it or don't want to have anything to do with science or math, and that's fine. These things can be very helpful. If you like math and science and that kind of stuff, it can be very, very useful to you as an animator, which is annoying because I always thought, I'm never going to use calculus. Well, the velocity derivative graphs are literally the graph editor. Joke's on me. I use it all the time. But if that freaks you out and you're like, I never took calculus, I don't want to do math, don't think about it like that. It just helps me understand it because I already learned it for math and I'm just reapplying it here. But you don't need to know math to make this work, so don't sweat it. All you need to think about is what happens when a ball bounces. So the idea is that it's slow to begin its descent, speeds up with time, hits the ground very quickly, bounces back up, which relates to Newton's law of motion of every action has an equal and opposite reaction. So if something comes in at 100 miles an hour and bounces, it comes off more or less at 100 miles an hour in the other direction. A little bit of energy is lost to heat or whatever, but comes in really fast, leaves really fast. So now we're getting the idea of something that we're animating being visually represented in some kind of a curve here. And what does this really mean? This is where people struggle. So here's my best kind of tips to help you understand what's happening here and to kind of remind yourself what matters to look at. Now I'd like to give you 3 rules to keep in mind while you're dealing with your graph editor, while you're trying to come to terms and understand what these different curves and splines of motion mean and represent. I want to give you 3 rules, 3 things that can help you keep it all right in your mind. Rule number 1, flat means no motion. Flat is 0, no motion, no acceleration, nothing. So here I have a cube, and what I've done is I've keyed the cube at frame 1, I've gone ahead to frame 20, I've set a key here. We're currently looking at the translate X, which is the motion left and right from the current camera position. The line is straight. It is just totally flat left and right. Because remember, on this particular graph, these frames represent time. These numbers over here represent the values that you could put up here. If I come over to here to the middle and I go over to the right, it's increasing the number. If I go to the left, it is decreasing the number, changing the slope of the line. Now, flat is 0. We've established that. That's rule number 1. Rule number 2, if the line, the curve, is not flat, and it is going up or going down or whatever, if that line is straight, perfectly straight with no kind of curving at the end, no tapering, if it's perfectly straight at whatever angle, that is a constant velocity, a constant speed. It's not changing, it's not getting faster or slower, it's just going. On frame 1, it's over here, and frame 10, it moves over here. Now I pointed out it needs to be straight, right? This is a curved line. So I'm going to change this from auto, or wherever it's currently at, to linear. Now it is straight. From here to there, it is one speed. It is that same speed going the opposite direction. So you can see here, the box is moving left to right at a constant speed in either direction. So what I'll do is I'll go 3 frames in either direction. I will take this and I will make it linear. Here we go, linear. So now what I have is a straight line, a flat line, and a straight line. Straight line moving, straight line flat, straight line moving, straight line flat. So you can see it moves, it stops, it moves, it stops. Now the third rule is where things start to kind of help you actually animate, and that is that if a line is going farther away from flat, flat being 0, meaning it's getting steeper, more towards a vertical line, you can't get a totally vertical line, an undefined line, because that becomes stepped tangents. So quickly, if I just jump over here to Maya and I change it to step tangents, you can see that a vertical line entirely is this little dotted line. And that's essentially teleporting, right? This is the fastest anything could ever travel. It just instantly appears, it takes no time, it just is in a different location. As something is going away from horizontal, more towards vertical, it is speeding up and getting faster and faster. The more vertical, the faster. Versus if something is becoming more horizontal over time and it's slowly kind of tapering out to a horizontal line, I mean just decelerating, it's slowing down, it's coming to a stop. It may not come entirely to a stop, it may just kind of turn into a more horizontal version of whatever it was doing before. For example, if I change this to auto, I'm going to take the straight lines away. I'm going to say that this gets a little bit bent and this also gets a little bit bent. I'm going to do both of these so that they sync up. Now if we look, the box doesn't actually stop anywhere. It just gets slower. So if I go ahead and take this part here, this is going from a flat line into a more vertical line, and here it kind of levels out for a little bit and then starts to come back towards over a horizontal line. This means we're going from slow into a more vertical line, meaning this is the fastest it ever really gets, and then it becomes slow again. This is the dictionary for reading the language of these curves. The flatter, the slower. The steeper, the more vertical, the faster. And it's the transitions between these things that give you the different interpolation types. So if we go ahead and take these keys and shift them sooner, meaning they happen quicker, obviously the motion needs to happen faster, snappier. And you can see that because the line is now more vertical. It's a steeper incline. It's going closer to the stepped vertical tangents, meaning it's going to happen faster, closer to teleportation, right? So if I play this, you can see it. Sound effects are totally essential. And this is how you control your timing. You have to understand how the graph editor works to really go in and troubleshoot to see like, why is this motion like feeling slow or swimmy? It can help you so much to be able to open this tool up, to look at this and say, okay, I like how this is happening really quickly, but I want to have it maybe a little slower, like where this goes right over there. Maybe you want to slow that down. So how do you do that? How do you diagnose this curve? Well, you just go to the part that is really fast, that happens right there. You say, well, to make it slower, I need to take it further from vertical, make it more horizontal, closer to 0. So what you do is you take these keys and you shift them over, move it way over. Now it slowly kind of goes back and forth again, versus if I go all the way and it happens over one frame, it's teleporting. It's basically going from this frame to that frame. It's as vertical as it can get. So those are the 3 most important rules of the graph editor. Flat is 0, no motion. Straight line is a constant speed that's not accelerating or decelerating. It's just going at whatever constant rate that slope would entail. Versus when something is curved and it's not straight, curved means changing. It all depends on rule number 3, which is closer to vertical, faster, closer to horizontal, slower. And the changes between those two give you all of this. Now, one last thing with this cube is we've only looked at translate, but all of this works exactly the same for rotations and scales and everything else in Maya, or whatever tool you're using. Because if I take the rotations, and let's just say rotations in Z, which is this. If I key this motion, and I go to 10, and I spin this 180 degrees-ish, flip it over. I'm gonna click rotate Z, and you can see it dips down. Whatever the attribute is you're controlling, in this case, it's about rotation. So don't think about like the position of the corners or any of that, just think about it's rotating. That's all it's doing. It's rotating in whatever direction you told it to, which means a steeper line. So if I take this over and make this a steeper line, it means it's going to rotate really, really fast. Versus a more kind of shallow, not so steep line, it's going to rotate slower. And then you can see if we play this at speed, you can't even see what happens those first couple of frames. It's moving so much so quickly, we can't even register the motion. So if the rotation's kind of broken and you're not really seeing the right things, either we need to slow down that rotation so that we can appreciate a little bit more. So there is a faster and a slower spin. And you can see the timing here. Fast and then slow, fast and then slow, fast and then slow. Now what really starts to get tricky is when you start introducing different rotations in different directions and we start really playing with this in all axes. Like that's where these things start to get complicated. So if we start looking at all 3 of these rotations and this thing's moving around in all different directions, it gets really hard to diagnose this because you start to wonder like, okay, which one is making it spin what direction? This is where it gets tricky. And this is why you want to block things really smart and have lots of keys before you let the computer do any work. Now finally, with those 3 rules under our belts, we can go back to our bouncing ball and we can just do the one thing we need to do to make this look more natural and like it's actually obeying gravity. So we have 2 balls that are just kind of floating around. They look very floaty, they don't look real. I'm gonna take the right one and I'm gonna correct it. Now what we wanna start with is something starting up here and slowly falling down. We actually kind of already have that. It starts up here and it slowly starts to come to a more vertical speed. The problem is when we get to the ground. When something goes to hit the ground, it doesn't cushion and touch the ground, it just falls, right? So the curve should be flat at the top and more vertical as we start to fall and it starts to pick up speed, and it really won't flatten out. It'll just reverse. So it should be this in the same way that the ball is actually gonna bounce and make that same kind of an arc. It's actually what it's gonna look like here. So if we fall down with our graph, in here we can see it starts to go back towards horizontal, going back towards 0, stopping its motion. We don't want that. Now just moving this handle isn't gonna work because you can see it's moving both sides and we don't want that. We just want to control the down and then the up separately, which is what this little V is for, break tangents. This little thing means that you can separate the left and the right sides of the handle. If you don't see this button, it might mean that your graph editor is too small and you need to scale it out so that you can see more of the buttons. So I click on this key and break tangents. You can see that they kind of turn into these little dotted lines, but now I can grab the left side and I can change it. So now what we have is, let me stretch these out really quick. So now what we have is kind of a flat line as it slowly gets sharper and it falls quickly. It never slows down, it just gets more and more vertical and then it hits the point of contact and it has to reverse and bounce up. So it has to go the other direction. So we go from down to up or whatever it is in whatever case you're dealing with. Then it flies up and then it slows down and loses its verticalness. It goes to horizontal as it loses its speed. I'm just gonna copy this key and paste it into these other 2 spots rather than having to do it again. That's a good tip for you. Just copy paste when something's working. So now if we look at this, it's a little bit more natural. So if you, instead of wanting like boom, 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 and you want it to be more stylized, you want it to be poof, poof, and you want more of this kind of a rhythmic thing happening, what you can do is just say, well, we want it to stop for longer. Bam, bam, and I just have a sharper, more vertical fall off. So what we'll do is we'll just stretch out this curve, and I'll correct this a little bit. I'll copy this guy, move it over there, make sure that this line is working well on each side. Copy, paste, and paste. So now it spends more of its time up than it does down. It has this hang time, and you can really take it even farther if you want. We can really say that by this point, it's like up there. And you can really push this as much as you want. That's the whole point of animation, is like you can change the physics of it by changing the curve. So now the ball's spending most of its time up in the air, and the only thing left to do is to add the squash and everything else. So if we compare the graphs of these two balls, you can see the difference of one of them being very smooth versus the other one having sharper points at the bottom, which give it kind of that aggressive change of direction, which a ball has when it bounces, comes up. That's that aggressive change of direction, giving you that pointy line. But either way, I hope this was helpful, and don't forget that I will be making more graph editor videos in the future that go deeper into the tools and the menus and all the different things for workflow and how to use this really, really efficiently if you already kind of understand how this works and you just need to figure out how to be like a monster of efficiency using the graph editor to animate your shots. Now, if you're still having a hard time and this wasn't enough to kind of get you up to speed with the graph editor, I highly recommend checking out my Patreon down below. We do a lot of Q&As and review sessions and things like that where I teach a lot of this stuff, and it's a lot easier to teach in person over a Google Hangouts, over a Q&A, than it is on a video. You wouldn't believe how much footage I have to edit through. This video is hopefully not that long. I've been sitting here for 2.5 hours trying to figure out how to explain all this the right way. So feel free to drop some questions in the comment section down below, or if you need more in-depth help, head over to Patreon. But that's it for today. I hope this video was helpful for you guys. I hope I did a good job of explaining and that you can take all this and use it to be more effective as animators in Maya or Cinema 4D or Blender or whatever tools you're using. All right, I think that's about it. Thank you guys so much for watching, and I will see you in the next video.